Well, we're stoked to have you at SPC, Lev. I know you joined us as a member pretty recently, and you come from a really interesting background, right, of exploring quantum cryptography and then now exploring some of the frontiers of quantization and how we think about models going forward in the future. Also loved that you were able to come and demo tonight. So maybe to get us started, would love to hear a little bit more about the story of your demo. How did the idea come about? What was the experience of building it out like?
Yeah, so for anyone with a background in maybe like algorithms or computer science theory, you know that, over a span of 30, 40 years, algorithms become much more efficient. And sometimes there's big breakthroughs, sometimes smaller. And I guess the initial idea for the things I've been working on, which quantization is a huge field, but how I got into it, was just like the realization that there's probably still a lot left on the table for how do you compress these models further, right? Like JPEG over PNG is a huge compression. And compression as a whole is a huge field. And so that got me thinking a lot about, and I had a little bit of a background in mechanistic interpretability at that point. And through that, started thinking a little about how do you compress models, make them smaller. Of course, initially I was going completely in the wrong direction for like a month or two, which is like how I learned. But yeah, and then I got really interested. I read this like BitNet paper, which I think a lot of people have read, where you can represent a lot of this model using -1, 0, and 1 for every weight. And it seems to kind of work, though, there's challenges and trade-offs there. And that got me down the path of more towards quantization. And so now, like tonight, demoing some quantized models, how do you run them for cheaper? And so one model we're demoing is going to be like pushing past state of the art as far as we can, in terms of what you can find online for a small model. And then also just not so much state of the art, but how do you combine all the different pieces to get much faster inference for a cheaper cost.
Tell us a bit more about what got you excited about the BitNet paper.
Yeah, I think like from a theory background, like there's a lot of interesting questions there. So these models, we're all told live on this continuous manifold, like live in a continuous space, and we should think about things as being like over the reals. And somehow, like, I think earlier you see in mechanistic interpretability some of this idea of sparse probes, sparse autoencoders, that somehow there is a level of discreteness going on. And perhaps that's clear looking back because you have like a bunch of nonlinearities in the model that are in some sense like quite discrete, like ReLU's either on or off, and sure there's continuous variance. But the BitNet paper, I think, like kind of started shifting my thinking of like, okay, like no, like these models can in some sense live over a lattice, like a much more discrete thing is happening where like somehow it's not so sensitive to small perturbations in real space. And like there's a lot more mathematical richness underlying these models than I previously thought.
I think that confluence of theory and application is really quite fascinating right now in the ecosystem. I mean, part of how we operate at SPC is very much bottoms up, starting with the founders that we gravitate towards and then exploring alongside them. And amongst many other tailwinds I've noticed, I'd say over the last year, one of the real patterns I've seen is that theoreticians, as you might think of them across a wide range of fields, math, physics, quantum cryptography, it could be anything, are really flocking toward this general question of what does a institution that does really cutting edge research look like in 2030, in 2035, in 2040. And naturally, there's a lot of obvious reasons why. Is like, hey, like, you can make billions of dollars now as an academic where you could otherwise couldn't really commercialize your technology. But I think it really probes at some of the core questions in technology writ large, which is where will the frontier of theory actually even emerge going forward? And as somebody who was in academia, I'm curious, do you believe that companies sort of are the way that theory gets pushed forward in the future? Or do you even believe it's sort of humans and people doing that, or some hybrid between models and humans? Like, tell me a bit more about how you see theory advancing writ large.
Yeah, I mean, of course, I can't say I'm like sure where it's going to go as a whole, but I think there's multiple things going on. So Terence Tao, like the world's premier mathematician, talks about experimental mathematics coming back to the forefront. And so like some different works where you're running a lot of experiments, running a lot of simulations, and of course a lot of AIs like this, and you're using that to check your hypotheses. So it's not so much like you're proving things. And so AI makes that the cost of doing that like really decrease dramatically. You're not spending 6 months writing this code base, maybe a few days. And so you can test kind of hypotheses and directions you want to go in mathematically. And so from a theory perspective, like theory does a lot of inspiring into like the AI world. So for example, like I wouldn't say that much of my work right now is particularly theory in the sense I'm not sitting down with a pen and paper and proving things. But like the theory background is guiding my intuition for the experiments that I want to run, which of course is wrong a lot of the times, but that's where you kind of have to iterate. So I do think that there's still a lot of theory which does not make sense to be done in industry just because like a lot of math, there's no real, commercial value to like some of the math. I'm not going to say which specific fields at risk of upsetting some mathematicians. But yeah, but on the other hand, like there's also a value to having a good theory that like actually tries to mathematically describe AI. I don't think we're actually fully there. A lot of people are trying to do this, but then it would be relying much less on intuition and perhaps much more on like mathematical formalism. So like, physics underwent this transition many times where people run all these experiments, there's a state of uncertainty and you're trying to formalize it using math. But we're not quite there yet. I do think it's possible that will come out of industry and not of academia. I hope that answers your question.
Well, I mean, pulling on that thread a little bit more, right? If you believe that there's this emergence of experimental mathematics, and I'm sure that analogy will apply to a lot of disciplines, right? Maybe there's this intuition of experimental coding where you're not actually sitting down and handcrafting each pixel, but it's kind of like fucking around and finding out and just seeing maybe the most effective 100x engineer is just somebody who's really token maxing all the time and is just exploring a bunch of things, and maybe they create a lot of waste, but then they're also creating a lot of really high signal product as well. And so I'm curious, if you believe in that rise, what are the traits that you think are really important in the people that you might want to work with or pull together that might not be super obvious to somebody who doesn't really maybe agree with that?
Just one quick point about the rise and then to the traits. A lot of math that's done today, like with proofs, are like incremental mathematics, where I really think that like AI would be able to just write the proof itself and you can check. And like we already kind of are there for a lot of things. In terms of what type of person, I think that like what you index on is going to change a little bit, where technical skill is still important because you needed to understand the structure, like the maths, but like the creativity and the aspect of like being able to generate a lot of ideas and also have the ability to very quickly evaluate them becomes much more important. Because if AI is good enough, like specific parts of technical skill, like the AI will be pretty good at doing specific parts of the proof. But of course, a lot of proofs today still require a lot of creativity, where it's not quite clear like at what point AI will be able to do. But definitely the more rote mechanical parts you can index less on and index more on creativity.
Well, I mean, we'll get to sort of small models, but maybe as a segue to get to small models, do you believe in a future of small teams? Like, do you think that really cutting edge companies need to stay small?
For what type of companies?
For the type of company that you think is going to push the field forward in AI.
Oh, for AI. Yeah, I think it's completely possible. I think it depends what side of AI. Yes, I think it's totally possible for AI.
I mean, implicit to that question, it seems like you might be of two minds of different types of businesses, right? Maybe walk through a little bit more. Like, do you see sort of a heterogeneity in the different kinds of businesses that might emerge over the next 5 years?
Yeah, for AI specifically, I think it's one of those questions that will be more like very obvious in hindsight, and like right now it's not clear.
We'll look back and be like, damn, we were such idiots.
Like in one direction, there's like eye of Sauron idea where the big labs will take over everything. And it's like in some sense a quite appealing idea because, if coding models are good enough, you'll be able to just like one shot a lot of these SaaS companies. And yes, there's also a lot of but on the other hand, there's like a lot of stickiness in terms of the B2B side of things. So I think that's like a lot more industry dependent. But I think that like if you're going to do an AI lab itself, you're not going to really be able to stick around unless you can just be better, right? Like if you're going to start, let's say, a Neo lab, and that Neo lab is not going to be able to compete on many axes, or like it only slightly competes on one axis and it's much worse than the other ones from the other companies, it's going to be pretty hard. So there's not many, let's say, huge companies that are like doing super well, or like that are doing super competitive models right now in the US. Like if you look at China, like it's pretty impressive. Like all these companies just pop up overnight. And the models are actually like quite good. I was using DeepSeek V4 like extensively today, and pretty surprised.
Share a bit more about that. I mean, I think
Yeah.
this is an axis that, I really enjoyed when we first got to know each other, is that I actually feel like on some dimension, you're probably top decile, top 1% of people in America who are obsessed with these Chinese models and like really understand what's happening, at least as a user of the models, maybe not as a creator, but what's going on in China right now?
Yeah. So, I mean, from the model perspective, they just are doing a lot of innovation in the open to some degree. Like they're publishing a lot of papers. I think it's closing off a little bit right now, but they publish models openly, and there's a lot of like innovation towards making models cheaper and also making them, I guess, more effective per unit of cost. So for them, it's very often compute, but they're also just more effective all up and down the stack. So DeepSeek was the one that sparsified models a lot. So like, OpenAI was doing a mixture of experts internally before, but not to the same degree as DeepSeek. And there's a lot of technical challenges and like hurdles to overcome to do that. Yeah, they're just producing really cool research. There's also a lot of really cool research out of the US, but I think a lot of the really cool research in the US is also just behind the companies.
Doors,
So it's closed doors.
Tell us a bit more about why making models smaller and more efficient is actually a North Star that you kind of want to spend a lot of time thinking about.
Yeah. So I think there's like small means a couple things. So the 2, 3, 4 billion parameter models are very cool and useful, and you can do a lot of things with them. But I think the question is just like, how do you take the biggest models and just make them smaller? Not like maybe not like on the order of a few gigabytes, but how do you 2, 3, 4, 5 times smaller? And I think if you do this, you can just decrease the cost per token a lot. So, right, like all these companies are burning so much money on compute, and people that are using like APIs know how expensive they can get very, very quickly. So if you're able to compress models in a way that's like compute efficient to actually run them, you will be able to bring down costs a lot.
Is cost per token actually expressive as a metric for quality along that axis, or are there other second and third order? I mean, I would assume that speed as well is a really important dimension of this too. Like, is cost per token actually like a sufficiently expressive metric, or are there sort of second and tertiary metrics that you're also really curious about?
So it's not sufficiently expressive in the sense that if you have a model that per token is 5 times cheaper, uses 10 times more tokens, than the better model, then that's obviously more expensive. And so like you need to have a model that actually gets like the job done that you give it. And still be cheaper per token. So you can also have a model that's maybe much more intelligent per token. So I think like really the cost per token metric's a little bit like fungible and a bit strange. But when you like cost per unit of like sweet bench or something, I don't know.
Or cost per unit of work or something like that. It's interesting. I think going back to something you said earlier around a lot of the Chinese ecosystem, I think one of the things that I remember being so sort of groundbreaking when initial DeepSeek results came out was the results around how little compute they use relative, right, to a lot of American labs. And I think there's this idea that we think about a lot at SPC, which is constraint breeds creativity. And I think that the overall ecosystem, I mean, you mentioned the Eye of Sauron framing that we were talking about earlier in SPC. There's a lot of constrained thinking, right now, which is, I think frontier models are going to eat lunch in this domain. We're scared of these other model companies. We're scared of the new neolabs that are coming that are getting tons of capital. So it feels like this interesting tension between immense opportunity, but then everybody seems well-funded and everybody seems to be hungrily ambitious for everything. So it creates this really interesting sort of state of superposition where you both feel a ton of constraint around what part of the pie you can start tackling, but then also immense opportunity everywhere you look. And I'm curious, when you think about building a business for the long term, how do you think about holding those two things in tension? Like, do you just generally believe that the opportunity exists and we'll just keep executing and then there will be great value that comes out of that? Or how are you sort of like navigating those two opposing tensions?
So I guess as you said, there's all these different companies and they're all unique in their own way. Or as far as I understand, they're all unique in their own way. In part because there's just like so many directions you can go in terms of like AI research and how you can translate that AI research into like some sort of business. So like from one end, let's say you want to just keep it simple and like, let's say we want to take open source models and inference them. So how do you go about making that cheaper? You can secure a lot of compute or figure out a way to secure compute in a smart way with like secondary markets, kind of like SF compute, and bring down the cost per GPU hour. You can try to make the models smaller, as we talked about, to make them cheaper as well. You can do like a whole lot of these things. And I think the question is, how do you, from a technical perspective, in terms of like if you want to win on the business side, how do you choose the directions to go in where you can stay ahead of other people and that advantage will compound? And also, I think that this question of like what will be the right direction or not, I think it'll become clear. And it's like, I think actually from the technical side, some things are becoming clear.
Sure.
But yeah, there's just like so many directions to go in. I don't know if it'll always be the case. That's like a million directions to go in and they'll be able to start, like every direction can start its own company.
Yeah.
I really think that in the end, like a company that's competing, like an AI lab-esque company or a company that's doing inference that's competing, will need to be good at all these directions.
Yeah.
You'll be able to, you have to do like everything at once. And that's like quite challenging.
Right. And in some ways, there's really novel problems that these companies are facing early into their tenure as businesses, right? Where with businesses that are working, you know, in year 2 or year 3, you might see 100x growth, where in old software world, we'd never really think of that as reasonable. You say triple, double, like that's a great company. That's like a world-class growth. Or Anthropic's 500% NDR that they announced earlier this week. It's like, that's ridiculous. You would never think about a business at that scale generating that kind of NDR. And so this kind of brings me to another thread, which is the new kinds of businesses and the new kinds of business models that might emerge as a result of the DNA of these companies being fundamentally different, right? It's no longer a team of product engineers, a team of go-to-market sellers. There's a loop where PM sits in the middle, shepherds feedback from a couple enterprise customers into the next product launch, and you keep iterating and you keep owning territories. It's very much this sort of Wild West of new breakthrough comes through, tons of attention flows to you, and you better be ready to handle all of this new demand or the frontier labs come and eat your lunch. And so it's a very different ecosystem that we're playing in, right? So I'm curious, what kinds of business models or ways to think about sort of strategically owning a business that is actually generating durable value? Like, how do you think about that forming?
Yeah. So I think from like the business side, you'd be basically have to be able to stay ahead and just offer a more attractive product. So like you need to be a lot cheaper, you need to be a lot better, faster. So there's like all these different ways of going about that. And that loops into the technical side of, let's say you have your one research breakthrough and you announce that to the world, and that's like where you're building a company off of. That's quite tricky because that one research breakthrough can be replicated with enough effort and work from these big labs. So you really have to like have some level of breakthrough all up and down the stack, right? So you have to like hyper optimize up and down the stack. Everything has to just be like tippity top shape. Which in some sense makes these companies like super hard to start. And that's why it's exciting. But
I mean, in some ways, like that sort of like dark forest, ultra competitive dynamic is not something that's super new to you, right? I mean, you had spent a lot of time in the cryptography world writ large. So it might be fun, even when we sort of got to know each other, one of the things I first noticed was this almost sort of like Sun Tzu, Art of War type sort of strategic thinking. And tell us maybe a little bit more about that background of cryptography. I mean, there's a lot of overlapping threads here, right? Where a product like Hyperliquid can just scale if it's the best product, where that wouldn't really happen in normal financial markets. So I'm noticing some overlapping threads between some other parts of your past. So maybe weave those things together.
So I've worked doing like applied cryptography and also I've done cryptography research. And the applied cryptography was often in the blockchain space. So for anybody familiar with like zero knowledge proofs and all those things, I've like written some code there and done some stuff there. And also like smart contracts back in the day. And like the blockchain world is super fun in large part because there's like a lot they can do and it can grow very quickly, as you're saying. And like very small teams can grow very quickly. I think like the most profitable per person team is a crypto company, if I'm not mistaken. I think like maybe like
wouldn't be
top 5. And part of it too is that in cryptography, like everything's kind of adversarial, and you always have to think about like the adversarial case of like what can go wrong in the worst way. But at the same time, I think that like it's pretty fun because you're forced to think about things definitely in a different framework. But there's things in cryptography which sound kind of like magic that come from the CS theory perspective, and now are like actually getting implemented into the real world at like Google scales. So Google like implements these things called like zero knowledge proofs in specific protocols. And I think it just kind of teaches you that oh, we can actually do a lot more than we think we can. And there's specific parts of cryptography and computer science theory which also kind of make you think and wonder about like where are we wasting so much compute, or like how can we do a myriad of these things better.
Where did you first get curious about CS theory at large?
Oh, I was a great professor in a great class at Carnegie.
What was the class?
CS Theory 251. So if anybody's been to CMU,
What did you like about the professor?
he just taught. I liked the way he taught a lot, and it like for me was the hardest class that semester. Like I failed my first homework. I just like, wasn't used to like that way of thinking. And it's just really cool. And then another professor, Ryan O'Donnell, I took multiple classes with an undergrad, who's just a fantastic professor. Yeah, and I think that it's really cool. Like I think that like I've also spent a lot of time doing systems, like lower level coding, starting in high school. And I feel like if you do, like, there's a certain time and place in life where if you don't do theory, then I don't think you'll ever like properly get to do
Yeah.
theory. And there's that realization that really made me want to like get into it.
Maybe as a way to bring us to a close, you mentioned this teacher giving you new ways of thinking. And in some ways, I think something that we're all grappling with is that these models are teaching us and forcing us to consider new ways of being and new ways of thinking. What are the ways that you're thinking differently today versus call it a year ago or 6 months ago?
Well, I think the models are getting good enough. We're now just like, let's just token max. Let's just like, if you just really figure out the right way to guide these models, like you can get a lot out of them. Still not everything. And I think that there's definitely like a lot of place for the human to come in and guide the models, figure out what experiments to do, like what new things to try. But yeah, it's really cool. I think it's like a very exciting time.
Sweet. Appreciate you joining us today.
Thank you.